Fred, let's move on to our next question. This one comes from Richard.
Hello, Andrew and Fred. This is Richard from South Salem, New York, just north of New York City. Love your broadcast. And I have a question that's always troubled me or perplexed me, is the actual movement of stars in our galaxy. I know even though we have a spiral galaxy, all the stars don't move as if it's a big swirl to the blue Danube. But stars are going in all different directions. There are streams of stars from all gobbled up galaxies. There are groups of stars that formed at one time and are moving in the same direction, like the Ursa Major Movement Group. Is there a clear way of understanding? Yet at the same time, I understand there really is an orbiting around the galaxy that takes our sun about 200 million years to make a full route. So is there rhyme and reason to the movement of stars in the galaxy, or are they all moving in different directions, buzzing around this way and that? Thanks a lot. Look forward to your answer.
Okay. And thank you for getting in touch with us, Richard. Hope all is well in your little part of the world. Actually, it's a big part of the world. But movement of stars. I think God was playing snooker and went bang. That's what I think happened.
Almost that sort of thing. It's a great question and sort of goes to the roots of how we understand the motion of stars in our galaxy. And in fact, really goes back. Historically, it goes back to the time not long after Hubble worked out that spiral galaxies were very distant objects, and that we probably lived in one of those as well. Because at that time, that was not known. It was, assumed that we lived in a disk of stars. We knew we weren't at the center of the disk. Harlow Shapley proved that in 1919. But the motion of the stars in the galaxy, that was actually kicked off by Dutch astronomers. Jan Oort was the best known one, well known today for the Oort cloud, where the galaxy, where the comets come from, the reservoir of comets. But Oort and one of his colleagues, I can't remember who it was, I'm ashamed to say that, but never mind. I did write about it in...
His name is clearly Nort.
Yeah, Oort and Nort. Actually, I think it was... it's on the tip of my tongue. It was somebody like Hertzsprung, but it wasn't him. Anyway, never mind.
This is why they called you Fred. It's easy to remember.
Remember the damn name. Yeah. And what's it short for again? I can't remember. So yeah. Anyway, Jan Oort, and the reason why his name is the one that comes to mind is because what he did was he looked at the motion of stars in the vicinity of the sun, and if you think about the fact that these stars are all swirling around the center of the galaxy, he actually teased out from the individual motions of the stars what the underlying flow was. So Richard's right in the sense that the stars do have their own individual motions, but it's part of a bulk motion as well. So they've got what we call proper motions, which is their motions as seen from Earth, but they also have real space motions, which you can relate to the kind of average motion of all the stars at our distance from the center of the galaxy. And this was what Oort did. And it's why we have what are called the Oort constants A and B, which actually determine the motion of stars in the neighborhood of the sun and relate it to the rotation of the galaxy. Anyway, the bottom line is that you can measure all the motion, the individual motions of all the stars, and take a kind of average, and that is called the local standard of rest. It's an important concept. The local standard of rest is if you measure all the neighboring stars with regard to the local standard of rest, then what you're seeing is their individual motions, because the local standard of rest itself is the motion of all of them around the galaxy. I'm putting this very badly, but the local standard of rest isn't a standard of rest at all. It's the the right velocity around the center of our galaxy for stars at our distance. That's basically what it means. And so just to cut to the quick, or cut to the chase, I beg your pardon, wrong metaphor there, cut to the chase in Richard's answer. Yes, he's right, or Richard's question, he's right, that stars have their own individual motions. But on top of that, or underneath that, perhaps, they're being carried along by the rotation of our galaxy. So that it's like, I don't know. I mean, one way of putting it is to imagine it being a river flow with lots of people in rowboats rowing around on the river flow. They've all got their individual motions, but they're being carried along by the river. It's exactly the same.
Yeah, or a lotto machine where you've got balls inside a big ball and you spin the big ball and the little balls all do their own thing. Not quite, because they're being dictated by the rotation of the external ball. Anyway.
What's a lotto machine again?
I don't know. I tried.
No, it's good. I think stick to the river.
Yeah, the river's a good concept. I think we've used the river concept
we have,
before.
on a larger scale, because it's the way we envisage the way galaxies move. Galaxies also have their own motion as they're carried along by the Hubble flow, the expansion of the universe. So it's a...
All right. Thanks for your question, Richard. And finally, our last question for this week's episode. This is a question that comes from Paul, north of the border, and I'm assuming that means he's in Queensland, which could explain a lot about this. Paul has sent us a question. We've received in a format never, ever before done on Space Nuts. And I won't spoil it by telling you what he's done. I'll just hit the button and, yeah, let it go. Here we are.
G'day, Andy. G'day, Freddie. Hope this finds you going steady. No, not like those ancient Grecians. Struth, it's good to hear your audience is increasing. Now I got a little query, and I hope it's not too dreary. It involves event horizons and a spaceship and its chances of surviving. I know we can use a planet's gravity to boost our rockets and throw them outside its grip and speed up on a parabolic trip. Could you use a black hole's massive gravity to up a ship's velocity and hurl it closer to the speed of light? I know it's a kind of a long shot, and even if you hit the sweet spot, would go and pass one, make you faster. Or would you just end up like your mama's pasta? Dearest Freddie, darling Andy, love your show, it's really handy. So from up north of your border, this is Paul who's suffering from space nuts disorder.
Oh, man, that is brilliant. That is brilliant. Wow. Never, ever had a question sent to us in that format ever before. But thank you, Paul. That was so good. Now, Fred, you know that music. I thought it was something else. Well, actually, I think it's what I understood it to be was adapted from something much more classical.
That's right. Yeah, the tune is from, it's actually the Dance of the Hours, or Danza delle Ore in Italian, which is a ballet in Act 3 of La Gioconda, the opera, by Amilcare Ponchielli, composed in 1876. And it's something I've known since I was...
Fred was there.
Well, I'd known it since I was a kid, because among the old 78 RPM records we had at home, that was one of them. And in fact, many years ago, I transcribed them all to digital format, and I played it last night just to remind me the quality is rubbish, sound quality,
Yes.
but the tune is there. And of course, it was heavily modified for Camp Granada, wasn't it?
Yes, that's
several
right. Yeah.
decades
Hello,
ago.
mother. Hello,
That's the
father.
one. Now,
Yeah.
something that I should confess, Andrew, which only a few people know, is that whenever I listen to music, particularly a song, I never listen to the lyrics. It's always the underlying music. And so if I hear a rock song that I like, it's not the words, because I don't hear the words. I just hear the music. And, you know,
Isn't that interesting?
folk or whatever it is, it's always the music. And so I was so captivated by the music there that I didn't really properly hear Paul's question, but I think it was about.
Well, I think I think I can nutshell it. He was asking, he was saying, like, we can get gravity assist through slingshotting around planets. Could we do it by using a gravity assist on a black hole, or would we get spaghettified?
I thought that was it. Yes, I got the impression it was. So the way to avoid being spaghettified by a black hole is to go past it sufficiently.
Is to never go to Queensland.
That's right. I do. By the way, there was a nice allusion. I did listen to the words at the end because I thought I'd better listen to this. Very nice lyrics, Paul, and I like the allusion to his mother's pasta, which of course is spaghetti. Very good. Yeah, being spaghettified. So if you're going past it fast enough, then you won't get pastified. You won't get turned into spaghetti because you'll basically just whiz by it. And that's what happens to the star S2, which is the closest star to the supermassive black hole in the center of our galaxy. And its orbit is certainly being influenced by the black hole. But whether you could use that for a gravity assist is a question that I suspect has a negative answer. Because as I understand it, and I should really check this, but I think it's not so much the mass of a planet that lets you do a gravitational slingshot by flying by it. It's the way that mass is distributed. So you've got something, you get close enough to it that you're feeling mass from, you're feeling the gravitational attraction, not just of the planet as a whole, but of different parts of it. And they are what affect your ability to transfer momentum from the planet to the spacecraft. Now, with a black hole, by definition, its mass is all concentrated in a single point. So I suspect that might preclude the idea of using it as a gravitational slingshot. But it's something I'd like to try and check with my colleagues.
Okay.
You can bet your life I'm going to listen to that again because it's such a brilliant, and the lyrics are very, very nicely done.
I'm very sorry to say that if we were to try to slingshot round a black hole with Paul, all would be lost. But I think the ukulele would survive.
Well, it might go up in pitch because you've got the gravitational time dilation.
Yes.
I don't want to steal Paul's thunder here, Andrew, but I might just give a quick shout out to another musical genius who was in touch with us recently, and we never got back to him, and I hope we can at some point, and that's Jesse James Allen, who wrote essentially a symphonic work celebrating the Cassini mission, which is something very close to my heart. And so it was the Cassini tribute. In fact, it's on www.cassinitribute.com. Brilliant stuff, Jesse James.
It is
fantastic. On the other hand, what we've just heard from Paul is no less brilliant in its own way, even though, that ukulele there, pretty great stuff. Maybe it doesn't
awesome.
compare with a synthesizer reflecting an entire symphony orchestra. Never mind, it's all good stuff. It's all music. That's my view. It's fantastic.
I got one more surprise. Seeing you mentioned Cassini.
Okay.
Fred. Yeah.
Oh no! No!
Goodbye, Cassini, your mission's fini.
I'll save you from
Yes. Yeah, that was somebody with a voice not very different from the one you're listening to now. So I too was inspired by Cassini, and somebody wrote that it's from La Donna Immobile. It's the tune, which is another operatic piece, and the Planetary Society commissioned somebody to write some words, but they only wrote one verse. And that was the start of it there. And so I wrote another two, I think. And I did perform it around the time quite a lot in for talks and things like that. And in fact, it was in South Australia that recording was made. So that was my one contribution, which is somewhat less musically talented than Paul's ukulele, and a lot less.
I have been though waiting for a perfect opportunity to use it. So.
There you are.
It's been sitting there for months.
Fell right into that one. Sorry. It's on YouTube.
Yeah.
If anybody wants to hear the rest of it, you can find it.
Yeah, Goodbye Cassini, it's called, isn't it?
That's right.
There you are. Well, we don't usually have a musical show, but it's been really delightful today.
Yeah,
so thanks to everybody who contributed. Thank you, Paul. Lovely to hear from you.
Great stuff.
I was going to use, because we had two Pauls on the show today, I was going to say it's an appalling show, but it wasn't.
No more appalling than any of the other ones are.
Oh dear. Anyway, thanks for all your questions. Thanks for contributing to Space Nuts for another week, and we got so many questions, Fred. We're going to have to probably do this again in the not too distant future. So we'll catch up with everybody real soon. So thanks again. Thanks for listening. Thank you, Fred. As always, it's been great fun.
Yeah, good to be here, and thank you for your wit and humour in the meantime.
Dark humour as it is sometimes. Yeah. All right. We'll catch you next week, Fred.
Thanks,
See you later.
See you.
That's Fred Watson, Astronomer at Large, part of the team here at Space Nuts. Thank you for joining us, and we look forward to your company next week. Until then, bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.